Hi friends, welcome back to the channel. For the people who have already subscribed my channel and for the people who have recently found my channel, a hearty welcome to this channel. I am Yashwardhan, an electronic enthusiast and electronic engineer who likes to work with electronic circuits and I make videos about explaining about different concepts in electronics and also different circuits. Now, in the previous video, I have covered one of the important principles which is called the voltage division principle or voltage division rule. The topic and I also discussed about when we are going to use it and what are its application in the practical world. If anyone has missed that video, I will keep the link in the description below as well as at the top of the I button also. You can watch that video afterwards. Now, the topic of this video is another important principle which is a counterpart of that voltage division only, which is called current division principle. Now, let us understand what do you mean by current division principle. The principle says that whenever you are having any current source connected in parallel with two different resistances, here I take the example for simplicity purpose. I took the resistances. You can have any other passive electronic component also. Like you have a resistance and RC circuit, R, L and a C circuit. That's also fine. Now what happens is that, and also here I am taking a DC circuit. That is whatever the current source I have connected, it is a DC current source. You can take an AC current source also. Then also there will be no problem. So now what happens is that whenever this current, whatever is the total current that is entering the node, that gets divided with these two resistances. Let us say if this resistance is R1 and this resistance is R2, then the current will always get divided in the ratio R2 is to R1. That's very important to understand. Whereas in voltage division, if you have R1, R2 in series, it gets divided into R1 is to R2. Here you get R2 is to R1 ratio only, it gets divided. As here in the example, both the resistances are having equal resistances, so the current get equally divided. Now let me change one of the resistance value to, let's say, a standard value like a 10 kilo. Now you can observe is that whenever I change the resistance to a higher value like 10k and this is a 1k resistance, you will observe along 1k kilo ohm resistance we are only 9.1 milliamperes of current, whereas across through the 10 kilo ohms we have 9.1 microampere of current is passing. So based on this we can say that whenever you are doing current division, across more resistance span, less current will flow. Across the less resistance span, more current will flow. And this is very important to understand because whenever you are considering a circuit, practical application like any kind of load like a refrigerator, microwave, oven, everything, you should always take into consideration how much current should flow into that load. Based on that, you should either try to increase or decrease the load, the resistance of the source. Otherwise, it's very problematic. Now, you may ask me, what is the application of this circuit? Now, this principle is very much used in many different circuits. Like in the parallel RLC circuit, you are using to find the current across any component. Then it is also used in the DC biasing or DC analysis and DC and AC analysis of a transistor. That is when we are transforming the transmitter into its equivalent model, having a voltage source and the current independent voltage source, etc. Then it is very important. Also, this current division is very much important in order whenever you are doing the DC analysis and you have one part of the circuit where we have one current, that current is depending on some other current. Then also in order to find the current between parallel elements, it is very much useful. Now one thing to remember is that whenever you are dealing with current or voltage, you should always take into the sign of the value is very important. For example, here the current is entering like this. So this is 10 milliampere. If in the circuit, if you are in your notation, if you consider the current is flowing like this, then you should always take it as minus 10 milliampere. Same thing applies here. here this 909.1 microampere current is flowing in from this node to this node. So it is a positive value. If you are considering the current is flowing from the bottom node to top node, you should take it as negative of 909.1 microampere. Same thing applies here. So you should always take into consideration the current direction whenever you are writing the value. Now I hope friends you have gained a good understanding about the current division principle. If you have any doubt, please feel free to comment that down below. Or if you have any suggestion on what kind of electronic circuit should I explain next, please also feel free to comment that down below and I will make a video on that topic. As I have already mentioned that in the community post, I have kept a poll about what kind of topic should I explain in online by taking online classes. If anyone is or whoever is interested, please fill that poll, and accordingly I take the decision on how to conduct the classes. Now I hope friends you have liked my explanation. You like my explanation. I have understood the concept very well. If you like my explanation, please like this video, share it with your friends, and do subscribe my channel. And for the people who have already subscribed my channel, thanks for subscribing the channel and supporting the channel in this manner. And for the people who are new to this channel and are a good viewer of and likes to watch such content, please feel free to subscribe the channel so that you get access to this all information. Thanks for watching friends. And I will meet you again in a new video with a new concept. Until then, continue experimenting on different circuits and asking me about any doubts you are having in circuits. Thanks for watching friends, and have a nice day. And stay tuned to the channel to see more such videos.